So we continue question 9b from the May 2022 CSEC Mathematics past paper. Now, here, this is the working that we had before. Let me just erase some of the things that I have here. I just want to erase those things that wouldn't help us in the second part of the calculation. In part 3, I already copied that part of the question right here. Determine the bearing of t from R. So let's do that. When you say from R, bearing of t from R means you have a straight line between t and R. We have that already. Then you say from R, t from R means you're going to have the north line and the arc at R. Say from R. So this is our north line, alright? And then the bearing would be measured from the north in a clockwise direction. That will give you the bearing. Now, the thing is this. You already had 83 degrees here, right? That was 83 degrees from the calculation in the previous video. Now the thing is, that we're going to find some angle that could help us in determining what this angle is. Alright? Now, can you determine what the bearing of t from R is? And which angle do you need to find? I want you to pause the video, work that out, and let's see. Alright, you paused. What did you get for the angle? Let's see. Let's work it out. Suppose you find this angle. This angle could help you, Could try the sine rule, right? In finding that angle. Could use the cosine rule too, yes, but the sine rule is a bit easier to work with. You don't have to be doing a lot of squaring and adding and subtracting and so on. So, let's say you have this side 180 over the angle opposite to it, sine, it would be sine LRT equal the side which is 290 over the sine of the angle opposite to it, sine 83. What is 290 over sine 83? Let me make this a bit smaller. 290 divided by, let's use bracket for safety, the sine of 83 close bracket equal 292.118. Alright, 180 over the sine of the angle LRT equal 292.118. Was it that? Let me just check again to make sure. Oh, 289. No, this was a different calculator for this. That's what I did earlier. Sine 290 over sine 83, 292. You're right, 0.118. When you round it off, that's what you would get. Alright? So, That is that. Now, we could put 292 over 1, and then if you multiply both sides by sine LRT and divide by 292.118, or as they say, you do some cross multiplication business, what you would get is 180 divided by 292.118 equals sine LRT. What does that give you? Let's see. We want to calculate 180 divided by 292.118 and see what happens. 180 divided by 292.118 equals 0.616. 0.616 equals sine of LRT. So let's rewrite it, put the sine of LRT over here. Let's put it in bracket. Equals 0.616. Now, you know what to do to get the angle LRT. The angle LRT. Angle LRT equals sine inverse of 0.616. And what does that give you? Angle LRT equals. Let's find the sine inverse of that. All right. It would be on the calculator here. It should be, let me see now. Sine, I don't see a sine inverse. This calculator doesn't have a sine inverse. I know most scientific calculator would have an inverse for the sine, cosine, and tangent. Oh, okay. All right, so sine inverse of 0.616. What do you get for it? Equals 38.025, 38.029, I mean, degrees, 38.029. So you have 38.029 degrees. All right. What could use? Just use 38 degrees. It's bearing, so you write 3 digits, 038 degrees. All right. Now, what next do you do? The thing is, if you should continue this line here, I use it as a dashed line, this angle would also be 38 degrees. This is not a bearing. I didn't need to write this with 3 digits. This one is not a bearing, so I just write 38 degrees. When you're writing bearing, you write with 3 digits. But this angle is going to be 38 degrees too. All right? Now, you have part of that angle so far. You have 30. Oh no. Wrong thing I did. Wrong thing I did. Let me redo those things. All right. Here, if you continue this line and continue this line, then this would also be 38. All right. But here, let's see what would happen here. You continue this line here and this one. As for This is 38. That's 38 degrees, right? All right, now here we're not going to use this 38 degrees, probably not at all, but oh no, what happened there? That's interesting. I mean, a while ago. Oh, well, no. All right. What we can do here is look at these corresponding angles. This angle would be the same as this angle, because remember, you extended this line, right? What was this angle again? Let's say the kilometer on a bearing of, from L, R is on a bearing of 65. So this was 0.65. That was the bearing. So this is also 65 degrees. All right. This is 65 degrees. All right. So now this leaves another angle here. The thing is, we know the angle from here to here. You see that? It's 65. You saw what you did a while ago. What we need is the angle from here to here. We need this angle. Right? This is what we need right now. Call it angle blue. But the thing is, what we can look at is the fact that if you come from here all the way around to here, that would be the angle on a straight line. You see that? See that angle right here? That's angle on a straight line. What angle is that? It's 180. But if you do that, come all the way here, then you reverse, back half of it, back half 38. What you would get is what remains here. You see that? So, to find the angle blue would be 180 minus 38 degrees. Alright? It would be 180 minus 38. What is 180 minus 38? Let's quickly do that with our calculator. 180 minus 38 equals 142 degrees. 142. So our blue angle is 142 degrees. See that? Let me just erase some of this thing. Now remember, if you have certain parts of the maths that you don't see here, you could watch the video again. You could also make a comment about it. Alright? Now the thing is this. You have two angles there that you can add together. You have the 65 plus the 142 to get all of this. Right? That would be the bearing of T from R. Alright? See that? So, let's do that then. So 142 plus 65 degrees, 5, 6, 7, 6 and 4, 10, bring down the 0, carry 1, 1 and 1, 2, 207 degrees. So what you have is that angle is 207. So all of this angle now going all the way around, is 207 degrees. So that would be the bearing of T from R. Alright, so that is the end of question 9. We'll look at question 10 in our next video.